Hi, if you're watching this video, you really should have made sure that you've already watched the video on the first video on antiderivatives, or at least you're familiar with antiderivatives, because we're now going to go further and we're going to show you what happens if you have a twist on your antiderivative. So also for the purposes of this one, we're never going to solve for C. That's covered in the previous video, and that's not the point of this video. So we're just going to always have a plus C. I have this seemingly innocent derivative, and I need to swim back upstream to get its original function that gave birth to it. So I'm going to write down what I would bet you would get on your first try without thinking deeply. I think you would get sine of 2x plus 7x plus c, and you'd be proud of yourself. But if you're following my advice, which is every time you do an antiderivative, wipe your brain clean by wiping your hand across your forehead. Now that you've reset your brain, take the derivative to double check yourself. When I took the derivative of this, I would get cosine of 2x times a ninja of 2 plus 7, and then the derivative of a c is a 0. Well, the plus 7 is good, the cosine of 2x is good, but I had this pesky times 2 that resulted from that ninja. But you know what? That makes my antiderivative not work out. I have this pesky times 2 that I don't want there. So what I have to do is when I do my derivative, when I do my antiderivative, I have to tack on a coefficient of 1/2 that will help battle out this extra times 2 that was a nuisance. This extra 1/2 is actually a way to fight a ninja in reverse. We're fighting ninjas in reverse in this lesson. So I'm going to erase that, because that was me checking my first antiderivative attempt, and it told me I was wrong, and it told me what I needed to battle, which was the times 2. So now if I took this one and wiped my brain clean and took its derivative, I would get a 1/2. Oh boy, big time wrong. This needs to be sine. Sorry for the messiness there, but that's now sine. All right, when I take that derivative, I would get a 1/2 cosine of 2x times a ninja of 2 plus 7, and then the derivative of the c is a 0, so I don't really have to write that. And notice this 1/2 and this 2, they multiply together to give me a 1, which is cosine 2x plus 7, which tells me I'm correct. So 1/2 sine 2x plus 7x plus c is the antiderivative. Because there was a ninja in there, we had to fight the ninja in reverse. That's the point of the antiderivatives with a twist. Okay, let's look at this next one. I chose this one, and by the way, all this annoying waviness is because I'm doing this outside, so I apologize if this is really, really crazy on your eyeballs. Okay. So first of all, I look at this one and I say, you know what? That x on the second term is in the denominator and it has an exponent of 1. That's a clue to me that this is going to be a natural log antiderivative. And over here, I might have my brain think about it like this. 1 minus x to the 1/2 power, because now I can use reverse power rule, and that square root doesn't really lend itself to reverse power rule. All right, so we've got to go ahead and do this antiderivative. So what I would start with, and I'm not saying I'm going to be right, so I'm going to do it over here, and we'll see if I'm right. I need a 1 minus x, and I need it to be to the 3/2 power, because when I take this derivative, the exponent has to lower by 1 unit. Well, right away I can tell if I took this derivative, I would get a 3/2 1 minus x to the 1/2 power. So this doesn't have a coefficient, so now I need a 2/3 here. Well, now it seems like if I take this derivative, I end up back here. But watch what happens. If I truly took this derivative, the 3/2 times the 2/3 would be a 1. 1 minus x to the 1/2 power, which is good, but check this out. There's a ninja of times -1, a very stealthy ninja, which would give this a coefficient of negative, but that coefficient is positive. That means I need a negative there to battle that negative. That's a confusing thing. So I'm going to now be confident that that is the good antiderivative of the first term. Okay, I can double check myself and take that derivative if I want. And then I'm going to end this with 2 natural log of x. Remember, the antiderivative of natural log normally will put a absolute value to assure that the input into natural log is positive, and we're ignoring the plus c. So if I think this is correct, what I have to do is take the derivative of the whole thing and make sure I end up back there. If I can do that, I've got it. If I can't, then I need to make an adjustment. We're going to do one more. I think I'll have to come up with a solution to these dancing shadows issue. All right. So I have an f prime, and I want to swim back upstream to get my function f. And you probably notice, because you're on the lookout for this, that we've got a reverse ninja situation brewing. I have e to the blah blah blah, but remember this, if I have y equals e to the x, the derivative is e to the x, but if I had y equals e to the 2x, the derivative would be e to the 2x times 2. We have that little ninja. So there's a ninja up there for me. So here's what I'm going to do. I'm going to piece it together. Function f is going to equal e to the 2/5 x. And now if I took that derivative, I would get e to the 2/5 x times a ninja of 2/5, giving me a coefficient of 2/5, but I needed the coefficient to be 2. So I need something on here so that it combined with the multiplying by 2/5 gives me 2. So what I say is, what mystery coefficient times 2/5 would give me a 2? That mystery coefficient can be solved via algebra, and it ends up being a 5. So this is using algebra to help me with this trial and error. Some people can just figure this out just by daydreaming about it, and that's fine too. But in the end, you just have to make sure that when you take that derivative, you end up back there. And by the way, this is not a natural log antiderivative because the exponent is not a 1. So I would view this as 5x to the -3. And when I do my antiderivative, that means I need a -2 in my exponent, because when I do the derivative, it has to go down 1 unit. And then I say to myself, what's that coefficient going to be? Well, -2 times some mystery coefficient has to end up giving me a coefficient of 5. So that mystery coefficient is -5/2. I would have the plus c. And now if I took this derivative, we've already verified this one. This one would be negative 2 times that is positive 5, x to the negative 3. Math checks out. All right, so the big deal on this lesson is there are reverse ninjas waiting for you in your antiderivatives. This was a reverse ninja, this was a stealthy reverse ninja, and this was an awkward and clunky reverse ninja. Be aware of those on your antiderivatives.